Yeah, Hi all. Welcome back to the 11th week of TA live sessions for AI SMPS. Before we get started, can anyone confirm if my audio is clear and if my screen is visible?
Yes, sir, it's clear.
Okay, thanks for confirming. Just a couple of points before we get started. Um, I'm a bit under the weather today, so I'll be probably going a bit slower. Other than that, there's nothing else. Let's get started. So this week we'll be dealing with a lot of logic. Okay, this is kind of an introduction to uh, knowledge representation that we do in AI, and there's also a proper full course on this by Professor Khemani himself. It's called Knowledge Representation and Reasoning, and it's probably offered in the alternate semester. So next semester it will probably be offered again. And if you find it interesting, you are welcome to take it up. One underlining point is that, like the previous few weeks, this week is also going to be more scoring, so try to make the best use of it. Okay, so coming to the question, here we are given two statements. Path is empty, this is the one, this is the first statement, and count is different, this is the second statement. And we are said that, or we are told that P stands for the statement path is empty, and Q stands for the statement count is different, and not Q. So this small symbol in front of Q is called negation, right? So this is negation of Q stands for the opposite of what the statement stands for, right? So count is the opposite of count is different would be count is same. That's what not Q stands for. Now you are given two statements below, A and B. Okay, A says path is non-empty or count is same, and statement B says negation of path is empty and count is different. Now given statements A and B, um, whether they are equivalent or not, that is what we have to find. And if they are equivalent, we have to we have to identify the equivalence formula from the given options over here, A, B, C, D, E, F. So which one do you think would be the correct option? I'll let you try to think about it for a minute and then we can discuss the solution. So we have a couple of answers in the chat box. Let's solve it and let's try to see which of them is the correct option. Okay, so let's write down whatever is given to us. Okay, we are given that P stands for path is empty. Okay, and Q stands for count is different. Okay, now statement A that is given to us, that says that path is non-empty or count is same. So look at the structure of this statement. It is first of all connected by an OR operator. Okay, and there are two parts to it. First part is path is non-empty, and how do we represent that? So path is empty is represented by P, so path is not empty will be represented by not of P, right? And then we have an OR over here, so we will have an OR operator. Now what is the second part? Or count is same, right? And how do we represent count is same? With negation of Q. Yeah, is there a doubt? Okay, maybe not. Okay, so this is what is represented by statement A. Let's look at what statement B is representing. Statement B says negation of something. Okay, so negation of this whole thing. So let's write down the negation part first. So there is a negation of something. Okay, we'll close the bracket when we fill it in. This part is again connected by an AND operator. Okay, and there are two parts. The first is path is empty, which is represented by P, and the second part is count is different, which is represented by Q, right? So this becomes P and Q. Now if you expand this expression B using De Morgan's law, what will we get?
Negation P or negation Q.
Exactly. So when we expand this, we will get negation of P, this AND will become an OR, and negation Q, which is exactly same as what A is. So we know that it is actually an equivalence. Now the only thing left is to decide which of the expressions denote the represent or tell us the correct equivalence formula. So A is not correct because we know that Q is also involved. B is also not correct because we have not of P and Q, not of negation P or Q, right? So if we look at expression B over here, we have not negation of this whole thing, which is P and Q, not P or Q. So option B is incorrect. Option C seems to be matching with what we had, right? Negation of P and Q, which is equivalent to not of P or not of Q. So this is part B, statement B, and this is statement A. Okay, so the correct option would be option C. Any doubts there?
No, go ahead.
Okay, that's great. Let's move ahead. So this is the second question. Given a knowledge base represented by KB of true statements, okay, so this is given to you. Entailment is concerned with which of the following? So which option is most relevant in case of entailment?
It is A, necessarily true.
Yes, so we have one vote for option A. I think others also might agree with this. A is actually the correct answer because entailment is something that is concerned with deducting state or deducing statements that are necessarily true given a knowledge base. Okay, so a knowledge base, given a knowledge base of true statements, entailment is concerned with identifying statements that are necessarily true given a necessarily true as a consequence, and the other statements are incorrect Obviously, C and D are not at all concerned with what we have. The only confusing option might be option B, but we know that statements that are possibly true, the statements of the truth value of which we are not yet sure about, that is not something we would call entailed from a knowledge base. We can say that they are provable from a knowledge base, but not necessarily entailed from a knowledge base. Okay, so this was more of a theoretical question. You might recall it from the lecture video, lecture slides. Nothing too much logical about it. Shall we move ahead then? Any doubts here?
Okay.
Okay. Now coming to question 3, which is now that you learn the definition of entailments, you will apply that concept to solve this question. Here you have to select the valid entailments from the given 6 options. So basically you have to select the options that are necessarily true given this knowledge base that is represented on the left hand side of the entailment sign. Okay, this is the entailment sign, and you have to tell me which of them are valid entailments. So I'll let you again think about it for a couple of minutes, and then we can discuss the solution. Hi Sachin, yeah, this is the 11th week of TA live sessions for AI SMPS. Although clarifying, this is not the lecture videos, those are available on the Swayam portal by Professor Khemani. Sachin, yes, sure, we can do that, but probably at the end of the session today. Let's first complete the questions for today from week 11, and then we can have a look at the doubts you have from week 5. Okay, let's try to solve the question. Before that, do we have any partial solutions or guesses on which of these are valid entailments?
If I'm not wrong, I'm getting all are possible.
Okay, let's have a look at all of them one by one and let's see which of them are actually valid and not valid. Okay. Okay, so the first one given to us is let me just write it down. It says P implies Q is a fact in the knowledge base. Okay, so this is number one. Our knowledge base is P implies Q and P, and we are said that we are entailing Q. Okay, so we have P implies Q and P. By definition of P implies Q, we will imply Q, right? So Q has to be entailed given this particular knowledge base, right? So the first one is in fact a valid entailment. Does everyone agree? Okay, seems like it. Oops.
No, no. Repeat the second. What is that means? P equals Q and P.
So P implies Q essentially says that if P is true, then Q has to be true. Okay,
Yes,
so
yes, yes, yes.
written in English words, we can say that P implies Q means if P, then true, then Q.
That is I know. At the bottom we wrote P again.
Oh, so this is just writing the two facts one after the other, right? So P
Okay.
implies Q is like we used to do arithmetic in childhood, right? 1 plus, like this is, let's say, 11 and we have 2. So the sum of
Okay.
these two will be so and so, right? That way.
Okay. Okay. Okay.
Yeah.
That's it. Just ask, like, sometimes the notations are confusing. Rather, can we equate and can we do the analysis using a truth table?
Yes,
Uh,
yes, yes. Truth table is actually a very,
it's yeah, easy to understand and simple to solve also, right?
yeah, yeah. So truth table is a sure shot way of arriving at these entailments because that will give you a definitive answer, and that will almost always be correct, right? Unless we make a mistake while making the truth table.
And,
But the thing
and
is that we can use the truth table method only for very small formulas or small knowledge bases. As the size of the knowledge base increases and the complexity of the formula increases, we cannot really use the truth table method efficiently, so we have to resort to other means, which we will also have a look at in the next few questions.
okay.
Okay, so let's look at statement 2 now. Statement 2 said that P implies Q is given and not of P is given. Okay, and it
So
said that
P is true, Q is true. If not P is true, then not Q will also be true.
um, okay, so we are given that P implies Q. I'll come back to your question. P implies Q is given. Okay, so if we had be if we were told that we have P is true, then we could have said that Q is true, but we are given not P, which means P is not true. Using this, we cannot say that not Q is true. This is actually not a valid entailment. I'll give you an example. Okay, um, let's say Q represents grass is wet, and P represents it rained. Okay, so if we were given that it rained, we can definitely say that the grass will be wet. Okay, but if we have said that it did not rain, not P, we cannot definitively say that the grass is wet, right? Because so see, we have said that it did not rain, but maybe a kid came and threw a glass of water on the uh, ground, which made the grass wet. Okay, so even if P is not true, Q can still be true. So using P implies Q and not P, we cannot say that not Q is true. This does not happen. If on the other hand we were given not of Q, if we were given P implies Q and not Q, which means that not P has to be true, because Q can be true only if P is true. So if Q is not true as per this statement, then P also has to be not true. Okay, so this is a common interpretation or sort of application of the implication that happens in this kind of logical questions. Is that clear, or do you have any doubts about this?
So what is the thumb rule that we are saying? Like you, unless and otherwise it is the conditions are not stated in the clearly in the fact, you cannot go and make your own assumptions and then
Yeah,
give them.
yeah. So basically, with implication specifically, there are two rules that you must remember. Uh, Given P implies Q and P, you can always derive Q or entail Q. And if P implies Q and not of Q, you can always entail not of P. These are two thumb rules of implication that you always have to remember. Anything other than this, we cannot necessarily say that that is true. It may happen that P implies Q and not P, but there can be situations where not Q is true. There can also be situations where P implies Q and not P and Q. Okay, so we cannot say that Q is or not Q is entailed because of this given statement. Okay, so the bottom line is that this is not an entailment. Is that clear?
I think more practice required.
Yeah. So we will have a look at other similar examples as well, and in other than that, I'm sure practice assignments must have other questions as well. With practice, you will get a hang of this. Just to address one question in the chat box, Q implies R, P implies Q, P entails R. No, so here we are just given two implications, not any statements, right? Q implies R and P implies Q. We are not said whether P is true or Q is true or R is true, so we cannot necessarily say that P entails R. This is my understanding. Let me know if that makes sense. Okay, coming to the third one over here then. This said that not of P implies Q entails not Q. So let's write that down. We are given not of P implies Q. This entails not Q. Okay, so let's inspect whether this is a valid entailment or not. Let's break this part down. We are given not of P implies Q. P implies Q can be also written as not of P or Q. Okay, you can verify this using a truth table if you're not familiar with this, but this is an alternate representation of P implies Q, not of P or Q. And if you expand this using De Morgan's law, we will get not of P. This or will become an and, not of Q. This will become P because negation, and not Q. So this is what we arrived at, right, from here. And this and statement can be further broken down into two parts, P and not Q. So given this statement, we can say that not Q is derivable and it's necessarily true. So we can say that this is a valid entailment. Is everyone convinced? Any doubts in this one?
No doubt, sir.
But P is not reading not Q. We have to,
Sorry?
at the end we end up with two logics, P and not Q, right?
Uh-huh.
So not Q leads to not Q is okay, but P never leads to not Q, right?
Yeah. So here what we are doing is we are saying that this thing is true. Okay, and for this to be true, this has to be true and this has to be true because this is an AND operator. So P is also true independently, not Q is true independently. Was that your question or am I missing something?
Okay, agree.
Okay. Okay, then let's have a look at the fourth one now. D says that the fourth option says that in the knowledge base we have Q implies R, P implies Q, and not of P. All these three together imply not of R. This is the fourth statement. Now let's have a look at whether this is true or not. So we have Q implies R and P implies Q. If we had P to be true, we could say that not of Q is true. We could say that Q is true, but we are given not of P. Using not of P and P implies Q, we can't really derive anything. Okay, we can't say for sure whether Q is true or not true, and because we can't say anything about Q, we also can't say anything about R. Okay, so this is not a valid entailment. Is this clear?
Yeah.
Elaborate with it.
Sorry, can you come again?
Can you elaborate?
Yeah, so like we discussed a while back, right? Given P implies Q and not P, we cannot say for sure whether Q is true or not Q is true. Do you agree with that?
Yes.
Okay, so we cannot make a deduction about the truth value of Q. Because we cannot make a deduction about the truth value of Q, we also cannot make a deduction about the truth value of R, because R is dependent on Q in this knowledge base. So we cannot say that not of R is necessarily true given this knowledge base. Does that answer your query?
Q is dependent on P, right? So if it is not of P, it can be not of Q also, right?
No. If P
No.
implies Q and P, then we can say that Q is true. But if okay, sorry about the interruption. It's resolved for now. Let's hope it continues to record the session. Um, yeah. Yeah. Coming back to the fourth question, I got a bit lost. So, were there any doubts in option four? Okay, I remember there was one doubt about um, given P implies Q and not P, can we say not Q is true? Okay, let me write a truth table to sort this out. Okay. Okay, so these are the exhaustive values that P and Q can take. Um, true, 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 false, false, true, and false, false. Okay, coming back. Yeah, apologies for this constant interruptions. Yeah, so P implies Q can also be rewritten as not of P or Q, right? So let's fill in the truth table for this. So with P and Q as true and true, what will be the truth value of P implies Q? Anyone?
True.
Correct. It will be true, right? Because
Yes.
not of P is false and then Q is true. So not of P or Q will be true. With true and false,
False.
false, correct? With false and true,
True.
okay? And with false and false,
True.
okay. So this is P implies Q. Now let's write down not of P and not of Q. Correct? You agree with me on not P and not Q?
Right.
Now let's look at the places where P implies Q is true. Okay, so the places, let me use a different color. So P implies Q is true in this row, in this row, and in this row, and not of P is true in this row and this row. Do you agree with me? Now, so this one is actually not of use to us, because here not of p is false, so we won't really consider this one. We are only concerned with the bottom two rows where not of p is true and p implies q is true. Given these two rows, can we definitively say that not q is true?
No.
No, right?
Contradictory output.
Exactly. So when we are given p implies q and not p, we cannot definitively say that not q is also true. On the other hand, if we are given p implies q and p, so let me highlight those rows. So p implies q is true in these three rows, p is true in the top two rows. So this one and this one, and so here p implies q is false, so we don't really require this second row. In the first row we have p to be true and p implies q to be true. So in that case q will always be true, not q will always be false. Okay. Another fact that we had a look at is if p implies q is true, so this row, and this row, and not of p is true, not of q is true, which means this row.
And the last one, Q, not of Q.
Yeah, this and this. Thanks for that. So this is not really the second row is not really relevant to us, because p implies q is false over there, and this is also not relevant to us. This is also not relevant to us. So only the last row is relevant, where p implies q is true, not of q is true, and there you can definitively say that not p is also true. So is everyone now convinced about the two thumb rules that we had written? That is, when p implies q and p is given to us, we can definitively say that q is true. Second thing is, when p implies q and not of q, we can definitely say that not of p is also true. But we cannot say anything about these situations given something else, either not p or p or anything else. Okay, so these rules have some formal names. This is called modus ponens, and this I forgot what is it called. Does anyone remember?
Tolerance.
Yes, tolerance, right? Okay, now coming back to option 4. So is it now clear why option 4 is not a valid entailment? Okay, moving on to option 5 then, which is given p and q separately in the knowledge base. This together implies p or q, or entails p or q. Do you think this will be a valid entailment?
Yes.
So here we have said that p is true and q is true. Okay, so p is true, q is true. So P or Q, this will also be true, right? Because true and true or true is true. So this is a valid entailment. Do you agree?
Yes, sir.
Okay. Now coming to the last one, we are given P or Q. And we are said that this entails P. Do you think this is a valid entailment?
No.
No, right? This is not, because we have said P or Q is true. So this could happen when P is true or Q is true, or both are true, right? So we cannot definitively say that P has to be true. There can be a case where P is false but P or Q is true. So this is not a valid entailment. Coming back to the options that we had, so the correct options are A, C and E. To answer a query in the chat box, if P and Q both are true independently in the knowledge base, then we can definitely entail P and Q, because true and true will always be true. I hope that answers your query. Okay, shall we move ahead now to the next question?
Okay.
Yeah. So the next few questions will be based on this problem setting. So if you recall from the previous week, we had discussed some rules and working memory elements, right? This is a similar thing, but in the language of formal logic. Okay. So this A, B, C and D, essentially these are rules given to us, and this small a, b, c, d, e, f, these are facts given to us, or this is similar to, analogous to the working memory elements. Okay. So the first rule says that if a person is double vaccinated, note that this question mark x over here, this essentially refers to a variable in formal logic. Okay, so this question mark x can be replaced by either Abha or Arnav or Anisa, so on and so forth. Okay. So the first rule says that if a person is double vaccinated, this implies that the person can visit a concert. Second rule says that if a person is not vaccinated and if a person's RT-PCR is negative, then the person can visit the concert. Rule C says that if a person is single vaccinated and the person gets a jab, then the person becomes double vaccinated. Okay, so notice how each of these implications is leading to a if something then something kind of a statement or rule. The last rule says that if a person is not vaccinated and if a person is fully isolated and if a person gets tested, then the RT-PCR of that person would be negative. So are the rules clear to everyone?
Yes.
Okay, so maybe you can take a screenshot or pic of this set of rules and facts, and the next few questions will be based on that, so we'll have to revisit these. Okay. Okay, so I'm moving on to the questions now. The question says that given these facts in the knowledge base, those 6 facts in the knowledge base, right, this small a, b, c, d, e, f, and the rules, and we assume we apply forward chaining, then which of the rules will participate in the moveGen function? And we have to write against each rule the number of instances of that rule that form the moveGen with the above facts. So moveGen is essentially what are the rules that you can apply given the current situation, current state of the knowledge base. Okay, so I'll let you try to work through it for a couple of minutes and then we can discuss the solution.
Sir, I think your voice is not audible. Are you speaking or just presenting?
Sham, I'm not yet speaking. I was still waiting on to get a couple of partial solutions. I was preparing my whiteboard to discuss the solution.
Okay. Sorry, just now I have joined, so I'm not able to figure it.
Yeah,
Okay,
yeah,
sir.
no worries. Okay, let's try to solve the question now. So we are given these set of rules at the top. Okay, rules A, B, C, and D, and these are the facts given to us, these 6 facts. Now let's see whether we can apply some rule given each of these facts. So rule A is this: if a person is double vaccinated, that person can visit the concert. So using this double vaccinated Abha, we can apply rule A, and we can say can visit Abha. Okay, I'm not writing the whole can visit, but I hope you get the point. Okay, similarly for Arnav also same thing will happen. We will apply rule A, can visit Arnav concert. Okay, so rule A seems to be not applicable in any other case. Let's have a look at other things then. Rule B says that if a person is not vaccinated and RT-PCR is negative. So do we have anything like that? We don't have anything like that. So let's look at rule C now. If a person is single vaccinated and if a person gets a jab, so using combination of both these two rules, single vaccinated Aman gets jab Aman. Using both these together, we can apply rule D to get double vaccinated Aman.
Rule C.
Rule C.
Okay, rule C. Yeah. Thanks for pointing that out. Okay. Now given this double vaccinated Aman, we can again apply rule A and get can visit concert.
Sir, I think answer is like 1, 1, 1, 1. Like each rule will be 5 times.
So here we have 3 instances of rule A itself, right? So it can't be 1, 1, 1, 1. But we have arrived at this particular arrangement of the knowledge base. Okay, so we have added a few new facts to the knowledge base, which is this, and this. Can any other rule be applied to move forward? Nothing else is given to us, right? So we cannot apply any more rules, and this is where we stop forward chaining. Okay, so the number of instances of rule A were 1, 2 and 3. Number of instances of rule B were 0. Number of instances of rule
0.
C was 1, and number of instances of rule D
And
was,
D is 0.
yes.
Okay.
Okay, so 3010 is the solution. To address a question in the chat, yes, let's have a look at that towards the end of the questions from week 11. Okay, then we can have a look at the remaining doubts. Okay, shall we move ahead then? Is forward chaining clear?
Sir, once again, can you explain?
Yeah, sure. So basically the concept of forward chaining is, say this is your knowledge base. Okay, these are facts given in your knowledge base. Now using some of these facts, let's say using this fact you applied some rule and you derived some new fact, and let's say using a combination of two rules you applied some other rule and you derived another new fact. Now this becomes your knowledge base. Okay, and you repeat this process, let's say to derive one more fact, let's say rule 3, and this becomes your knowledge base. So basically what you keep doing is you keep adding to the chain as you move ahead. Okay, you keep adding new facts to the knowledge base, and you keep repeating this until and unless no more fact can be added or no rule can be applied to the given knowledge base. Okay, and that's exactly what we are doing over here. Given the 6 facts in the knowledge base, we applied whichever rules we could apply. Okay, so we could apply rule A to this fact and this fact, so we applied that. We could apply rule C using this and this together, so we derived this fact, and now given this derived fact again we can derive this. So this is how we did the forward chaining and arrived at the different instances of rule. Is that clear?
Yes, sir, it's clear.
Okay. Now moving to the next question. If forward chaining algorithm runs till no more inferences are made, which of the following facts will be added to the knowledge base? And I think we already know the answer to this. It will be can visit Abha, Arnav and Aman. The other two people, we don't have enough information to conclude anything about them using forward chaining. Okay, so C and D are incorrect, all others are correct. Straightforward. Moving on to the next question then. We saw forward chaining, now we will apply backward chaining. Okay. And this is kind of similar to the concept we saw in planning, if you remember, right, where we were given the end goal and we had to derive relevant actions, and those became the pre-sub goals, intermediate sub goals, and we kept expanding in the bottom to top manner, okay, from the goal to the initial state. It's something similar. So if the goal is can visit can visit a variable concert, which of the rules will be part of the move gen and backward chaining, and what are the relevant rules that generate sub goals, and how many instances of those rules we will find in place in the search tree rooted at the goal. Okay, so just to clarify, we will start at the goal. Okay, this is the root of your tree, and this is can visit concert. Okay, now we have to select which are the relevant actions that can be taken, or which are the rules that could give us this particular goal. Can you tell me what rule could that be, given this?
Double vaccinated.
Rule A, right? Yeah, double vaccinated. So double vaccinated will become the next sub goal. Okay, and then we will see which rule could give this, or which facts could give this. Okay, and
Good job.
sorry.
Good job.
Yeah, so this is rule C, right? Single vaccinated and get jab. So this is how you will keep filling in the tree, but I will encourage you try to fill the tree yourself first before we discuss the complete solution. Okay, so I'll leave this on here for a couple of minutes so that you can try to solve it yourself. I'll go back to the set of rules and facts given so that is easy for you. Yeah, so let's discuss the solution after a couple of minutes, when hopefully some of you have some partial solutions ready.
Sir, once again, just can you show the question?
Oops. Yeah, I showed the answer also by mistake, but still I would encourage you to try to solve it
Okay, okay,
yourself.
sir. Thank you.
Okay, while you're trying to solve this, there was a query in the chat box, so maybe I'll just address that in the meantime. So, what is modified modus ponens? I don't know if that is covered in these slides in this course, but okay, in any case, let's discuss that and go through it. So the normal modus ponens was P implies Q and P gives us Q, right? Now let's say in terms of formal logic, this is given to you in some variable format. And let's say PA. Okay, now usually what you would have to do is you would have to first substitute x with a. So first you will write this gives us P of a implies Q of a, and then P of a will be used in modus ponens to give us Q of a. So it's a two-step process, right? First is this one, second is this one. So what modified modus ponens does is, with this directly it gives us Q of a by assuming that this variable is equals to a. That's what I think modified modus ponens means, but you can also verify that. So again, to address this query, can you solve July 23 week 9 assignments? Can you post the question here? That would be easier for me to kind of have a look at rather than search what was the question exactly. So if you could post the question, we could have a look at it maybe towards the end of the session today. But coming back to the backward chaining problem that we had. Okay, so let me draw it again from the scratch. Okay. So this was our initial goal to begin with, right? Can visit X concert. And is there a single rule that gave this? Let me bring this down so that we can reference it whenever required. Okay, so rule A definitely gives us can visit concert. Rule B also gives us can visit concert. Okay, so there are two actions possible. One is using rule A, and the second is using rule B. Okay, and what exactly rule A says? Double vaccinated X implies can visit concert. Okay, this is one option, and the second is rule B, which says that not vaccinated X and RT-PCR negative this together implies can visit concert. Okay, now let's break this down step by step. For this, the prerequisite of the rule is double vaccinated X, so that becomes a sub goal. And what all facts or rules fulfill that? So let's first write down the facts that fulfill this. The first fact is double vaccinated Abha. We know that Abha is double vaccinated, right? So that fact fulfills this. Second is double vaccinated Arnav. Is there anything else that fulfills this double vaccinated condition?
Aman.
Aman does not yet fulfill it, right? Because that's not directly given to us in the facts, right? These are the facts given to us.
Okay.
Okay. What we can say is a rule. So rule C gives us double vaccinated, right? So let's write that down. Rule C, which tells us single vaccinated X and gets jab X. This together implies double vaccinated X. Okay, now these two are facts, right? So we can't really go any further, so we stop here. But this we can expand further. So now what becomes the sub goal? This part, right? The prerequisite part of the implication, which is single vaccinated and gets jab. This becomes the sub goal. Okay, this can be further broken down into single vaccinated being an independent sub goal and gets jab being an independent sub goal. Now, is there any fact that satisfies the single vaccinated? It's single vaccinated Aman, right? Because we have said that Aman is single vaccinated. And similarly, Aman also gets a jab, right? That is also given to us. So again, now we have reached a fact. We cannot expand this any further. So we stop here. So this part of the tree is now filled. Let's fill up the other part of the tree, which is coming from rule B. So here what will be the next sub goal? Not vaccinated X this has to be AND, because both these need to be satisfied. And RT-PCR negative. Right, this can be further written as not vaccinated X and separately as RT-PCR negative, right? And this again will be connected by an AND, because both these need to be solved in order for us to solve the goal. So is there anything that gives us not vaccinated? Any fact? It's not vaccinated ANISA, right? We have one fact.
C and D.
ANISA. C and D, let's have a look at that.
Ameya.
And AMEA, correct. Okay, again you can't go any further below from here, so you stop this subtree, but this one is yet to be filled, so let's fill that one. So which rule gives RT-PCR as the output? It's rule D, right? Rule D says that not vaccinated X and fully isolated X and gets tested X all these three together give RT-PCR negative. We are not writing the whole thing. This is essentially rule D. This will again be broken down into 3 sub goals, right? Which can be written as not vaccinated X, fully isolated X, and gets tested X, and all three need to be solved for us to solve this goal. Now this not vaccinated can again be filled in the similar manner, okay, with AMEA and ANISA. And we can't go any further here, so this is where we stop. And there is nothing that can actually satisfy fully isolated and gets tested, right? Because that is not given to us anywhere in the knowledge base, as far as I remember.
Yeah.
So this is the whole backward chaining tree that we have built. So is everyone convinced by the tree that we have built?
Yes.
Okay. Now let's go back to the question. The question asked us, what are the relevant rules that generate the sub-goals? How many instances of those rules will find a place in the search tree rooted at the goal? So essentially what we have to do is count the number of times a rule was part of the search tree. Okay, give me a moment, I accidentally closed the tab. Yeah. Okay, So how many times does rule A find a mention here in the whole search tree? Let's use green to mark that. Anywhere?
At the top it is there, right?
Yes. So one instance, any other instance of rule A? No, right? So this is the only instance of rule A. Okay. Rule B has one instance over here. Rule C has an instance over here. And rule D has an instance over here. So each rule has one instance in the whole search tree. So our answer would be 1111. Is everyone convinced by this?
For this problem, 111, but is there any chance to get 2 in any situation?
Yeah, there is always a possibility. Depends on the problem and the initial facts given to us. So there might as well be a case where a rule might be instantiated more than once.
Okay.
Yeah. Okay. Now the next question based on the same backward chaining is, if the goal can visit X concert, which of the following goals will be reported as true by backward chaining? It's the similar output as forward chaining, but just the question is different. Which of these agents will be able to achieve the goal of going to the concert? If we have a look at the search tree, Abha can visit the concert through this route.
Arnav.
Yes, Arnav can also.
I think A, B, and E, sir.
Yes, Abha, Arnav, and Aman can visit the concert, all using these subtrees, the paths that I am just depicting. But Anisa and Ameya cannot visit the concert. So the correct options would be A, B, and E, as one of you just pointed out. Okay, that brings me to the end of questions I had for today. Unless there is anything specific to discuss from week 11, I can go into the doubts that were posted in the chat box for today. Okay, let's look at the doubts then. So first was Sachin, you had some doubts on week 5 practice assignment. Can you point me to the exact question that you wanted to discuss? Sachin, are you around?
Yes, sir.
Yeah. Dhanalakshmi, in the meantime, you had also had some questions from week 9 assignment. It's okay if the question is in the image format. You can still copy the text, right? Or you can try pasting a screenshot in the chat and see if they allow for pasting that. I think they should. Or if not, what you can do is you can take a picture of that question and you can post it in the discussion forum so that we can solve it now or later. Sachin, it's difficult to get the context of the question. Can you point me to the question number in on Swayam?
So it is from Big Five practice to assignment group 2.
This one? Which
Practice assignment to a group 2 question.
practice assignment part 1 or part 2?
Part 2. DSP BNB part 2.
Okay. And this is from group 2.
Uh, Group 2 not, it is from group 3.
Group 3, okay.
Uh,
Okay. What is this question that they're asking? Let's have a look at that. Branch and bound, okay. So it's a branch and bound question. They have depicted the setting over here. Branch and bound starts with a selection of two n edges that satisfy the lower bounding invariant. Each city contributes to outgoing edges. There are total of two n edges that guarantee a lower bound. Okay. Okay, so what's your query specifically? Like the answer to this question, is it not matching or
the answer is also not matching, and I am not getting the logic band. Is how
okay.
how can we?
Have you attended the live session for Branch and Bound before?
No, sir. I am.
Okay, okay, no worries. Um, so what I can do is I can take some time to think over this question, prepare a solution for this, and then we can discuss it in the next live session. Or if not in the next live session, we will have an extra live session on 16th of October, okay, which is the next Friday. So our 12th
Okay.
week live session is in the is on next Tuesday, which I suppose is um, 14th of October. Am I correct? Yeah. And then on okay, so 14th is one live session, and then one of either 16th or 17th we will have an extra live session. Okay, so we can also discuss these extra remaining questions on that day. The only reason being that I will also take some time to properly understand what exactly they mean by this kind of framing. This is slightly different from how I had explained BNB in the live session. So if I take some time to familiarize myself, it would be more convenient for us to discuss it. Does that sound good, Sachin?
Sir, I also have one more doubt from week 2 final assignment 2 question number 7, the DFS question.
Okay, let me do one thing. Let me note down all these. Okay, so first doubt was week 5 practice assignment. Uh, Practice assignment 2, group 3. Okay, and then you said which one? Week 2 main assignment,
Week 2 final assignment 2.
question 2. Okay, fine. I'll make a note of that.
So week 2 final assignment 2 का question number 7.
Okay, fine. 2 and 7. Okay.
Okay.
Can you include that kernel problem also, the one which you said?
Okay, okay. Kernel problem. Okay, fine. Okay, I've made a note of that. I see some other question posted by Varisha. Is that also from a practice assignment?
No, sir. Actually, my doubt is from a week 2 question about DBDFS. I am well aware with how DFS works, but it's just that I'm not able to get the tree for DBDFS right in the final quiz assignment of week 2. So if you could just make that tree for me, the rest of the questions I can figure out on my own on DBDFS.
Okay, can you point me to the exact question number?
It's week 2 quiz assignment question 9.
Question 9. Okay, fine. I made a note of that. Maybe we can discuss all these extra questions on the extra live session day. Does that sound good?
Sir, it would just take 2 minutes to like solve the tree. The rest of the questions I'll be able to do on my own. Just the tree I'm not able to get right.
Um, I can understand, but I would prefer to take some time. There's no hurry, right? I mean, week 2 has passed.
Okay.
Yeah.
Okay, sir. Sure. Okay.
Yeah, because I would revise a bit of DBTFS and then try to construct the tree.
Okay, sir.
Okay. Questions from week 9 assignment. Okay, fine. I'll make note of that. And Bhumika said that can you please discuss question 6, 7 and 8 from week 11. Is it week 11 practice assignment or the main assignment?
11, there are no practice assignments.
Okay, then maybe it would be better to discuss it post the deadline, so I would avoid that. Yes, I will upload the recording today itself.
Thank you.
Karthik, you had raised a hand. Do you have a query?
So one last ask, like, will you be able to summarize on the overall algorithms that has been discussed and maybe give some thumb rule or some important gist of it that will like help us to encapsulate everything and then get an overall understanding, like
If you can tell me some kind of an algorithm that most of you are having a difficulty in, then we can discuss that. But covering that
Okay.
for all algorithms might be a bit difficult task for me because we have 12 weeks of content, so many algorithms, and
Agree.
I will have only
Agree.
2 extra hours, right? So you
No,
can
that in between
yeah.
5, 6, 7, we are like the branch and bound, and then that there are number of variations out there.
Okay, so we can focus on those kind of algorithms like branch and bound and have a more a kind of a rediscussion on those kind of topics on the in the extra session.
That plus somewhere we do discuss about like the addressability as one aspect, and also the optimal solution, which algorithm will give you an optimal solution, which will not give you. So
Okay.
that kind of summary will help.
Okay, sure. We can. I'll make a note of that.
Yeah. Thank you so much. Otherwise, yeah. Thanks a lot.
SMGS, yes, Shiva. I've made a note of that SMGS method. Okay. Anything else before we end for today?
Hello, sir.
Yeah, Sham.
Yes, sir. Actually, I'm Shyam, sir. Last semester I was with you for knowledge representation and reasoning, and I personally messaged when I got my result, right? So I think you can remember.
Sorry, Sham. I don't remember, but
It's okay. It's okay, sir.
yeah, I'll check. I'll check again.
It's okay. It's okay. Not an issue, sir. So one thing is thank you very much, sir. Last semester, initially I was not confident of completing this course, knowledge representation and reasoning. And actually, when I was posting you a lot of notes, you told me one word. That is that once we complete this subject, we will be getting comfort in this. So now I'm really enjoying the comfort in the week 11, sir, because it is like kind of a recap of knowledge, representation, and reasoning. Right?
Yeah, that's
And
true.
thanks for your encouragement, and I could like say that I just followed your live session, sir. So because of that only I was able to clear last semester, and hoping to this semester also I'm doing the same. I'm just practicing the assignments and following your live session. So actually from week one I'm not exactly getting the time to join within the schedule, but today I have made the schedule. And thank you very much, sir, once again. What I can say is so last semester when I come into this course, now I'm feeling that last semester course is easy, knowledge, representation, reasoning. Because there may be many languages, but rules of inference logic is same. But here you see a lot of algorithms. Once again, I'm a bit tensed about the exam. But anyhow, as I got some past experience by watching your lectures and you just made me comfort, so I try to implement the same during this semester.
Thanks.
I'm happy
Thanks.
with these 3 weeks, sir. Like week 10, week 11, and week 12. I think I already watched that content.
Okay.
But I think constant satisfaction is not discussed in the knowledge representation. That is something weird. But week 10 and week 11 was really comfortable. And
That's
week 10, I really scored very good score. And it's everything goes to you, the credit goes to you because you explain the concepts in such a clear way. Hoping
that's
so that this semester, like I can able to, I'm already watching your live sessions from starting, but just I have missed many live sessions. I couldn't able to ask some doubts, but it's okay. They are manageable.
Thanks a lot
And
for your kind words, Shyam. Yeah, you are giving me a lot of credit. I think the major credit goes
no,
to you
actually,
for.
believe me, sir. Actually, last semester I have scored 61 marks out of 100. Just if I get 2 marks, I would be in the top 5%.
That's really great. Congratulations
That
to
is
you,
just
first of all.
that is
Let
just
me.
because of watching your lectures only, not watching regular videos. I used to just watch your lecture, practice assignments and these assignments, and just because of that I have cleared the exam. And you know that proctored exam pattern is Deepak Kimani sir. Proctored exam format is different from other exams. Like we'll be having many sessions and the number of questions also vary. Generally, 50 questions were asked in most of the subject, but these subject questions vary with a lot of sessions kind of thing. But anyhow,
Thanks.
this semester I'm tensed but a bit nervous too, but I'll try my level best.
Thanks for sharing your thoughts, Sham. Just to conclude, yeah, you are being very kind, but again, I will emphasize that it was your effort and you deserve the credits. As for the current semester, yeah, all the best to you and not just you, everyone who is enrolled in the course. I hope the live sessions are some help, but I would also encourage that don't depend solely on the live sessions. That might seem fruitful in the short run, but in the longer run, it's really advisable to properly watch all the lecture videos. If you have time, actually read the books that have been written by Professor Khemani and other pioneers in this field. That will give you the benefit in the long run. So yeah, definitely follow
Yeah.
that. And
Definitely, sir.
yeah.
I'm parallelly doing that whenever is required. But so what I feel is like last semester, many of us here are registered just because of the mandate was in AI domain. Because you know that this knowledge representation and reasoning, AI, such methods for problem solving, and another course, constraint satisfaction. These three courses are not like regular course. Like we need lot of effort to understand when compared to other NPTEL courses. And I believe that most of the like registered people are here to get that minimum criteria. Like we have to score minimum 55 marks out of 100 in order to obtain the domain certificate. So the first thing is like we have to fulfill that short-term goal. And similarly, with your encouragement, we definitely go through in detail whenever it is required in the long term.
Yeah, thanks, Sham. Yeah, I really appreciate, and yeah, all the best to everyone. Um, unless there's any other doubt, let's end for today and meet next week
Actually,
again.
sir, one more doubt is like, so whatever the algorithms that were discussed from week 1 to week, say week 9, that was fine. Like I was totally connected with this search method. But may I know the reason of introducing this knowledge representation and reasoning topic in the 11th week? Of course, if you talk about AI, everything is search. We can't deny it.
So this is
But it is
just to give you a flavor of the kind of knowledge representation aspect of artificial intelligence, and of course it's too less to 1 week is to 1 or 2 weeks is too less to completely cover
yeah, it's
everything.
very
So
very
that's
tough,
why
sir.
that's why we have other courses like knowledge representation and reasoning and constraint satisfaction as a separate NPTEL courses. But yeah, you can pursue those as per your interests.
Yeah. Actually, see, listening this 1 week and solving these assignments also, it is bit hectic, sir, because this forward chaining and backward chaining, we have that entire week lecture, like all these kind of questions. There were a lot of elaborated things. Still, there was some difficulty in solving the assignment, but 1 week, this crisp thing, and I'm already experienced that how questions will be asked in the proctored exam. That no direct questions will be given, right? But
I'm
still,
not
like if somebody has done that knowledge representation, this is easy. Then otherwise, bit hectic. But I'm enjoying it.
Yeah, that's great to
That
hear,
written
Shyam.
topics.
Yeah, I'll just end the recording for today
Yes,
because I don't
definitely.
see there are any questions.